So question 2, we have 3 friends are trying to choose a restaurant for dinner. Benedict wants Pizza Palace, Chandra wants Pasta and More, Ada wants Burger Barn. They decide to design an experiment that will ensure a fair decision as to which restaurant they will choose. On a standard 6-sided die, Benedict is assigned the numbers 1 and 2, Chandra is assigned the numbers 3 and 4, and Ada is assigned the numbers 5 and 6. The die will be rolled once, and the person whose number is rolled gets to pick the restaurant. Method 2, on a fair coin, Benedict is assigned heads and Ada assigned tails. The coin is tossed once, and the person whose side is flipped gets to pick the restaurant. Method 3, in a standard deck of 52 playing cards, Benedict is assigned the cards with club and spade suits, Chandra is assigned the cards with diamond suits, and Ada is assigned the cards with heart suits. One card is drawn at random, and the person whose suit is drawn gets to pick the restaurant. Match each method to the correct description of its fairness. Okay, fairness means that they all have an equal chance of being selected. So like in method 1, they both had 2 numbers assigned to themselves out of the 6, so they each had 2 out of 6, so that was fair. So fair because probability, okay, so they want to know the probability. So probability of chosen with method 1. So how many numbers were assigned to each person? They were assigned 2 numbers out of 6 total. So that equals or reduces down to 1/3. If you're not sure with how to reduce that down or familiar to it, you can type in reduce into the Symbol Lab calculator and type in 2 divided by 6. And it will show you cancel the common factor of 2. What does that mean? That means that 2 can be rewritten as 2 times 1, and 6 can be rewritten as 2 times 3. The common factor is the 2's, which reduces down to 1. Then we have 1 times 1, which is 1, and 1 times 3, which is 3. So that's how it reduces down. So we have method 1 has a probability of 1/3 because each person has a probability of 1/3. So method 2, on a fair coin, Benedict is assigned heads and Ada is assigned tails. There's no representation of Chandra, so that's not fair. So unfair because Chandra is not represented. Method 3, in a standard deck of 52 playing cards, Benedict is assigned the cards with the club and spade suits, Chandra is assigned the cards with the diamond suits, and Ada is assigned the cards with the heart suits. So I know that there are 4 suits, and Benedict is assigned 2 out of those suits. So the probability of Benedict being chosen is 2 of those suits, those clubs and spade suits, out of the 4. So that's 1/2. Now the other girl's probability of Chandra being selected is she's assigned 1 suit out of the 4, so that's 1/4, and the probability of Ada being selected, again, she was assigned 1 suit out of the 4, so that's 1/4. So it's not fair because Benedict has 50% while the others are both 25%. 50% is an equivalence of 1/2 and 25% is an equivalence of 1/4.